My name is Viru Kasivisvanathan. I'm an Associate Professor of Urology at University College London and consultant urologist, performing the diagnosis and treatment of patients with prostate cancer. So what we see on the screen is the standard type of MRI, which is a multiparametric MRI, which comprises three parts. The whole scan takes about 30 to 40 minutes, and nowadays about 30 minutes in most places. The third part of the scan involves a contrast injection. So that means a small needle in the arm with a dye injected into the body to help light up suspicious areas on the prostate. When you give contrast, because it's an injection, there does need to be a doctor in the vicinity in case there's an allergic reaction. Of course, allergic reactions are very, very rare, but you do need someone to be present just in case. There's the picture of the contrast injection being given. And when we take away that contrast injection, we're left with what's called a biparametric MRI. You can usually take around 10 minutes off the length of the scan. You don't need to give the injection, and you don't necessarily need to have a doctor in the vicinity because you're not injecting anything anymore. And you're left with the first two parts of the scan that comprise the multiparametric MRI. We spoke to patients about whether we should investigate the value of the contrast sequence, the third part, based on the fact that some studies had suggested it may not add too much in terms of cancer detection. So the PRIME study is an international study. It's carried across 22 centres in 12 countries and 5 continents. We have representation, of course, in the UK as the lead centre, but strong representation from Europe, North and South America, and some centres from Asia and Oceania too. The principle behind the study is that men with suspected prostate cancer who were referred by the general practitioner to the hospital underwent at the hospital the full multiparametric MRI, all three parts, but the radiologist reporting the scan was not able to see the contrast sequence. And they declared, based on the first two parts, what they thought was wrong with the scan. They were then unblinded and shown the contrast sequence and asked to make the same judgment on the full scan. And we carried out biopsies according to whether or not the short scan or the full scan looked suspicious or not, which allowed us to determine how good the short version and the long version were. The implications of the work would be that if the short version without contrast, the biparametric MRI, is as good as the detailed, longer version, we can have a shorter, more streamlined scan without an injection, which is going to be better value for money and may allow more scans to be done at the same time, increasing the accessibility of MRI to every man who needs one.